Okay, what we're doing today is learning a shortcut to do the problems that require us to go from grams to representative particles, or from representative particles to grams. They work exactly the same. They're just coming at it from a different direction. In both kinds of problems, whether we're going from grams to representative particles or representative particles to grams, there's going to be three fractions. Okay, in this case, grams to representative particles, which are atoms of calcium, we're starting with grams of calcium. Now, you may not realize this, but in the last problems that we did for the do now, these were exactly the problem that I am doing here, but it's less work. Okay? This works because I can do 10 fractions in a row if I want. And I can run the calculations in exactly the same way, which you'll understand later. But for right now, remember, I'm canceling grams of calcium, and then I'm going to cancel moles of calcium here. Now let's look at this side by side and see what the difference is so far. I'm all the way to the end of my calculation, and that's all I've written. All I have to do now is write the answer. What have I missed? What is it that I did not have to do? I did not have to do all of this. That's a pretty good deal. I didn't have to do this. That's not there. In fact, I didn't even really have to do this, because I'm going to do it all on the calculator in one swipe. And so all that's really here that you need to be able to do this problem properly, and by the way, probably much more accurately, is to take and get my given over 1, get it converted into moles, which was that first problem. And you see this number here? I had to carry it over to here, didn't I? I had to copy it. When you copy a number, you have an opportunity to make an error. So I don't have to do that over here. And then I don't have to rewrite the whole beginning thing over here. I can just write this one last fraction. And what's the thing that A atoms represents? What's the number? Yeah, this is our Avon number, isn't it? 6.02 times 10 to the 23. Okay? Now, here's how you can work this one. Would you all get out a calculator, please? And I'm going to stop this for my class so they don't have to watch, or you don't have to watch while they're finding their calculators. Whoa. Now, on your calculator, what I want you to do is, whatever you do, don't hit the equal key until I tell you to. Okay? So we're going to do this calculation. I'm going to go back to single screen. We're going to do the calculation to get the answer to this. So, first thing I do not have to worry about how I put that first number in. However, these are the rules for all the other numbers. See, calculators are stupid. Dummy, dummy, dummy. I'm holding up a calculator and calling it dumb. Anyway, so this guy doesn't understand anything about sig figs. He'll give you a whole long line of numbers that are meaningless because they have nothing to do with sig figs. It's the right size number, but they don't know sig figs. But here's how you talk to this calculator so that this dummy can understand what to do with the numbers you're putting in. Here we go. We take and when we're going to have a numerator as our next number to calculate, we have to hit the times key. Before a denominator, we hit the divide key. Now let's do it. Our first number, 6.14. Put that in. Now what about this 40? Is this going to be preceded by a plus, or I'm sorry, a times or a divide? This is definitely a divide because that's a denominator, and that's 40.1. Now don't hit the equal key. Now the A atoms is this number here, isn't it? We're just substituting it in. And by the way, in my class, A from now on means the Avo number. Okay? So now we need to figure out what we're going to do before we put in this 6.02. We're going to leave the 10 to the 23 and tack it on at the end like we did in that second or classwork problem. So times or divide? Times. Okay. Now we do times and 6.02 and hit the equal key, and you should be getting 0.921765586. You see, we don't need all that. Dumb calculator, but hey, we know how to manage it. So we're okay. So over here, let's get our answer started, and you'll be able to see how this works. So I'm going to start with my 0.92. Should I call that 921 or 922? 922, because the 7 to the right of the 1 on the calculator there is bigger than 5. And now I have 3 sig figs, and life is good. Now I have to take this guy down here, and this is 10 to the 23rd. Next thing I do is just change it into scientific notation. We move the decimal to the right, which does what to the power of 10? Decimal to the right. What do we do with the power of 10? Down. Okay, so we got 9.22 times 10. Instead of 23, it goes down to 22. Now, let's look over at the split screen again and see how that changed. Look at that. Look at how much easier that is. Isn't that nice? So this has to be your first thing, this is second, and this is third. You can't put this guy, well you could, I mean ultimately the numbers would work out right, but you need to be thinking if the grams is given, we've got to start with molar mass because we have to get to moles before we can get to atoms. And if we're starting with atoms, atoms is going to be over here, and the A number will be down here. Let me show you a really good summary, and you probably want to get this into your notes somewhere. Not here. Come on, let's go down. There we are. All roads lead to moles. What do I mean? Let's get an arrow up here so I can point for the people at home. And this guy, we'll make it a little bit thicker so it stands out a little better. And yeah, we'll make it a lot thicker. Okay. So this guy is my moles. You'll notice I have moles here as well. Moles is always in the middle of these calculations, and it's always on the top. Now, see, the molar mass in grams is for problems in number 13 as your second fraction. And the third fraction has the A number on top with moles on the bottom. So, how do I know what the grams will be in this fraction? Where do I go? To the table, yes. Okay. Now, if we start with atoms, we still have to go to moles. But the only thing that gets atoms to moles is the A number. Huh? So this is the model for doing all of your problems. All the problems in number 13 work this way. All the problems in 14 work this way. Making sense? Okay, I have for you the answers to all your questions. Let's see. Those are working out 13 and 14. But here you go for tonight. I just want you to know, whether you're watching at home or here in the classroom, your questions for last night in this class, the answers are here. So you want to check those out on your own at home. And if you're having problems and don't understand how those numbers came about, you need to ask me in class tomorrow. For today, we're going to work these in class, and we're going to work as many as we possibly can. The rest of the period is for that purpose. So remember what problem type 13 is. You're starting with atoms, so you got to go to moles. Problem 14, you're starting with no, your answer is in atoms. I'm sorry. So you were starting with grams, and you had to go to atoms. And here you were starting with, you were starting with, those are atoms, aren't they? That can't be. No, this can't be. This is all the same number. What am I doing? Okay, so this is the answer. The answer's in grams, so we had to start in atoms. Okay? So atoms was the answer in the first one, and you started with grams. And here you started with atoms, and your answer was in grams. Start with grams, got to go to atoms. Start with atoms, you got to go to grams. And the molar mass, or the AVO number, is going to be used to get you to the center according to this little chart. Okay? That's it, folks. I hope that helps. See you.